Complex rational expressions. A complex rational expression is a quotient with rational expression in dividend, divisor, or both. So let's simplify several problems. X plus 5 over x squared minus 16 divided by x squared minus 25 over x minus 4. Okay, so one thing we need to know that this type of expression, we can rewrite it, this complex expression, as a division problem, because this fractional line, any fractional line, meaning division. This one's also x plus 5 divided, this is also division. But we need this major one, fraction divided by fraction. Okay. So I'm going to rewrite x plus 5 over x squared minus 16 and divided by x squared minus 25 over x minus 4. And here, what am I going to do? X plus 5 divided by x squared minus 16. Well, x squared minus, okay, let me write down. And divided by x squared minus 25, x minus 4. So look here. We have x squared minus 16 and x squared minus 25. These two expressions follow the rule of difference of squared, which is a squared minus b squared is equal a minus b times a plus b. And I'm going to open it up. X plus 5, so x squared plus minus 16, it's going to be x minus 4, x plus 4, divided by x squared minus, x minus 5, x plus 5. And we divide by x minus 4. Okay, from here, we are going to do division of two fractions, which means I'm going to flip the second fraction. Second, you don't dare to touch the first one. If you flip the first fraction, it will take you straight to the woods and leave you there. Okay. Okay, let's now do the math division. X plus 5, x minus 4, x plus 4. Since I'm flipping, it's going to be multiplication. X minus 4 comes here. X minus 5 times x plus 5. Okay. Before I go further, I would like to mention that when you are doing rational expression, you have to watch out for denominator not to become 0. Because if it's rational, that means in denominator can be x, which is in our case it is. So our, let me see, denominator is this one, right? This fraction is our numerator, and this fraction is denominator. Therefore, we have to watch out denominator not to become 0. So what do we have? We can write down that x minus 16 cannot be equal 0, right? Because I'm using to divide this x squared minus 16, and x squared minus 25 cannot be equal 0. So from here, x cannot be equal plus minus 4, and x cannot be equal plus minus 5. So our x can be any value but plus minus 4 and plus minus 5. Okay, now let's move on and start doing simplification. X minus 4 will be cancelled with this x minus 4. and then x plus 5, x plus 5 will be cancelled with this x plus 5. And the answer is going to be 1 over x plus 4 and x minus 5. Okay, next one. The same idea can be used when simplifying complex rational expression that includes more than one rational expression in the numerator or denominator. There is however, there is a shortcut that can be used there. Okay. Let's see how we are going to do. Question number 2. We have 1 minus 9 over x squared and 1 plus 5 over x plus 6 over x squared. All right, let's solve it. So what am I going to do here? I'm going to bring to common denominator, combine these two fractions in denominator and combine these three fractions, in numerator and combine three fractions in denominator. So let me work this out. I'm going to rewrite the following way. 1 minus 9 over x squared. So our common denominator here is going to be x squared, right? Which means 1 I'm dividing by x squared and multiplying by x squared. Second fraction I don't touch. Okay, next one. 1 plus 5 over x plus 6 over x squared. Okay, so here we have three fractions with common denominator equal x squared. Therefore, I'm going to multiply this one by x squared. Here also x squared. Since here I have x, so I'm multiplying only by 1x to get x squared. Here also multiplying by x. And the result is, in numerator I'm getting x squared minus 9 over x squared. In denominator I will have x squared plus 5x plus 6 over x squared. Okay? And from here, I'm going to follow the example we did in the first case. It's going to be x squared minus 9 over x squared divided by x squared plus 5x plus 6 over x squared. Well, x squared minus 9, we are following as a squared minus b squared, difference of squared, which is going to be x minus 3, x plus 3, here is x squared, multiply, because I'm going to flip it. So x squared comes here, and x squared plus 5x plus 6. I can FOIL it, right? X plus 2, x plus 3. I'll put the method of FOILing in at the end of this video, so you can watch it if you don't remember or you don't know. Okay, so after this, actually one more thing we need to do, in we can figure it out what can be the domain in this case. So domain can be any number, but x cannot be equal 0 because of this, right? Here denominator, right? And x cannot be negative 2 or negative 3, correct? negative 0, negative 2, negative 3. These three values, it cannot be. Other than that, everything else, it's gonna work, can be considered as a valid number that does not affect denominator to become 0. All right, so let's cancel it. What do we have to cancel? X plus 3, x plus 3, and x squared we are canceling with x squared, and as a result we are getting x minus 3 over x plus 2. And let me move this condition here. So considering that this is not equal, negative 2, negative 3, and 0. Okay, thank you for watching. And I'll get busy with next video.